Hello guys, good afternoon all. Welcome to my YouTube channel CBK Engineering, and today we are going to be treating ordinary differential equation. But before we dive into that, you need to understand differential formulas and integration formulas as it will be used while solving ordinary differential equations. Now to differential formulas. If u and v are functions of x, y, a, c, n denote constants, and we assume that the derivatives of u and v with respect to x exist, then differentiating these is equals to du over dx plus or minus dv over dx. You just differentiate separately, having in mind of the sign that is in the middle. Number 2, differentiating cv is equals to c dv over dx. Remember, c is a constant, and in differentiation and integration, the constant will come outside while you differentiate the function of x, which is v. That's why you have c dv over dx. Number 3, differentiating uv. U and v are functions of x, so this is a product rule, and the product rule is you differentiate v, multiply with u, plus you differentiate u, multiply with v. That's why we have u dv over dx plus v du over dx. Differentiating v over u. V and u are functions of x, and this is a quotient rule because u is divided by v. This is a quotient rule, and a quotient rule, the differential of the denominator multiply the numerator minus the differential of the numerator multiplied by the denominator all over the numerator squared. Remember, the differential of the denominator, which is u, that is why we have du over dx, multiplied by the numerator, which is v, minus the differential of the numerator, which is v. That's why you have dv over dx, multiplied by the denominator, which is u. That is why we have u dv over dx all over the numerator squared, which is v squared. That's why quotient through differentiating this, you have v du over dx minus u dv over dx all over v squared. Number 5, differentiating this, the power will multiply everything, and the raised to power minus 1. That's the power will decrease by 1. But when this is okay, differentiating this, x raised to power n, you have n x raised to power n minus 1. Differentiating this, remember, use a coefficient of x raised to power n. Differentiating this, you have nu raised to power n minus 1 multiplied by du over dx, showing that you differentiated u with respect to x. Differentiating this is equals to a raised to power x natural log of the absolute value of a. Differentiating e to power x is the same thing, so you have e to power x. Differentiating this ln x, which is natural log of x, if you differentiate this, you have 1 over x. Differentiating sine x, you have cos x. Differentiating cos x, you have minus sine x. Differentiating tan x, you have sec squared x. Differentiating cot x, you have minus cosec squared x. Differentiating sec x, you have sec x multiplied by tan x. Differentiating cosec x is equals to minus cosec x multiplied by cot x. Differentiating this, sine inverse of x over a is equals to 1 all over square root a squared minus x squared. Differentiating cos inverse of x over a is equals to minus 1 all over square root a squared minus x squared. Remember, differentiating this and differentiating sine inverse of x over a and cos inverse of x over a gives you the same result. The only difference is the sign, which is in the sign you have positive, but at the cosine you're going to have minus 1 as the numerator. Differentiating tan inverse x over a will give you a all over a squared plus s squared. Differentiating cot inverse of x over a will give you minus a all over a squared plus x squared. And remember, differentiating tan inverse of x over a and cot inverse of x over a will give you the same result. The only difference will be the sign, which in tan inverse you have positive, and in cot inverse you have minus, which is negative, as the numerator. Differentiating sec inverse of x over a will give you a all over x square root x squared minus a squared. Differentiating cosec inverse of x over a will give you minus a all over x square root x squared minus a squared. Remember, differentiating sec inverse and cosec inverse will give you the same result. The only difference is the negative sign, which is you have minus a, negative at the cosec, and positive at the sec. Okay, that's all for differentiation. In differentiation formulas, all I need you to do is take your time and go through these differential formulas and try to understand them, because it will be used while solving ordinary differential equations.